Now see here in the today class, inshallah, we are going to do few more questions on the previous methods. Now let me take what is the meaning cap r vector. Generally we take xi plus yj plus zk. R vector means xi plus yj plus zk. A mod r can be written as small r. Its value is under root of x square plus y square, magnitude of the vector plus z square. Now if you square this one, root will go. So r square will be x square plus y square plus z square. So if you differentiate r square with respect to x, partial differentiation with respect to x, r square will be 2r. Now differentiation partially with respect to x means dou r by dou x. Now d by dx of x square is 2x. We are differentiating with respect to x, so y and z are constants. You take out 2 here, bring r on the other side, 2r by dou x equals to x by r. Similarly, we can take dou r by dou y equals to y by r, and dou r by dou z equals to z by r. So let me do few questions based on these methods. You just we have to use this in every formula, in every questions. Therefore you just remember all this r, what is r, what is r square, and dou r by dou x, dou r by dou y, dou r by dou z. Now see the question: if vector r equals to xi plus yj plus zk, then show that gradient r equals to vector r by r. And you see here, we have seen that what is vector r, magnitude x r square. This already just we have seen. Now let us start. What we have to prove? We have to take gradient r. Gradient r. This is nothing but del r. This is nothing but del r. What is the formula of del r? I dou r by dou x plus j dou r by dou y plus k dou r by dou z. This is the formula. See here, I into dou r by dou x, we are having x by r, plus j into we are having this y by r, plus k into we are having this z by r. So you take common from all this, 1 by r. What is left here? xi vector plus yj vector plus zk vector. This is nothing but vector r, so we got this as vector r by r. Vector r by r. Now next question is, see, gradient of 1 by r. We have to prove minus vector r by r cube. Minus vector r by r cube. We have to write all these steps. We already know that vector r equals to x. Then mod r squared dou r by dou x, dou r by dou y, dou r by dou z. Now we have to find the value of gradient of 1 by r. See here, gradient of 1 by r. What is gradient del of 1 by r? Del x is I dou by dou x of 1 by r plus j dou by dou, let's write here, I vector dou by dou x of 1 by r plus j vector dou by dou y of 1 by r plus k vector dou by dou z of 1 by r. Or we can use sigma word also. We can use sigma and solve. See here, there is a formula we are having. D by dx of 1 by x is minus 1 by x squared. D by dx of 1 by x is minus 1 by x squared. See here, I into, we have to differentiate with respect to x, but we are having here r. Let you differentiate r. Let me differentiate this with respect to r. So d by dx of 1 by r will be minus 1 by r squared. D by dx of 1 by x is minus 1 by minus 1 by x squared into, we have to write dou r by dou x, because we have to differentiate actually with respect to x. So therefore we differentiate r, must write dou r by dou x. Here we must differentiate and write dou r by dou y. Here dou r by dou z. Now see here, plus j into d by dx of 1 by x is minus 1 by r square, but we have to differentiate this to y now. So we write here dou r by dou y. Dou r by dou y. In the same way, plus k into minus 1 by r square into dou r by dou z. Dou r by dou z. So let we do one thing. Let we see here, plus into minus I vector by r square. Dou r by dou x we are having here. Dou r by dou x is x by y, x by r, y by r, z by r. So let me write this as x by r minus j by r square into y by r minus k by r square into, this is z by r. So let we do one thing, let we take common minus, we can take common 1 by r square into r cube. If we take this common, what is left here? X into I vector plus y into j vector plus z into k vector. Now this is vector r, so this will be minus, this is vector r by r cube, vector r by r cube. So next question was here, show that del of r power n equals to n into r power n minus 2 into vector r. So let me start here. These steps you write by yourself. Now I am writing the left hand side. What is del into r power n? Del is I dou by dou x of r power n plus j of dou by dou y of r power n plus k of dou by dou z of r power n. If you want, we can use sigma also. Sigma, you can write like this. Take out, okay, I into dou by dou x of r power n. After solving this, we can expand again. Sigma vector I. You see here, we have to differentiate with respect to x, but we are having r here. Let me differentiate r. What is d by dx of x power n? N into x power n minus 1. In the same way, d by dx r of r power n will be n into r power n minus 1. But we have to write with respect to x now, so we have to write dou r by dou x. Dou r by dou x. Now let me take out outside n. N is constant, we can take out what is left here, sigma I into r power, even r power is also constant, we can take this also outside, n into r power n minus 1. If I taken out outside, what is left here, sigma I into dou r by dou x. Now if you expand this, you will get three terms, n into r power n minus 1. If you expand, you get three terms here, I dou r by dou x plus j dou r by dou y plus k dou r by dou z. So we know this is x by r, this is y by r, this is z by r. So n into r power n minus 1, I into x by r plus j into y by r plus k into z by r. Now let me take common from this 3, we can take outside r, n into r power n minus 1 by r power 1. What is left here, xi plus yj plus zk. You see here, this is vector r. Now if you bring this upward, this is minus 1, minus 1, minus 1 will become minus 2. So n into r power n minus 2 into vector r. Now next question, if vector r equals to xi plus yj plus zk vector, then show that u dot delta, u dot del into vector r equals to u. How to start? See, let me take u vector as u1i plus u2j plus u3k. So let this be the u vector. Now what does it mean? U dot del means u is u1i plus u2j plus u3k dot, what is del? I dou by dou x plus j dou by dou y plus k dou by dou z. So what is dot product? We have to multiply I coefficient, j coefficients and k coefficients. We have to multiply I coefficient, j coefficients and k coefficients. So let me multiply I coefficients. You left with u1 dou by dou x plus u2 dou by dou y plus u3 dou by dou z. Coefficients of I, coefficients of j, coefficients of k. So we got this now. Now what is the next step? We have to multiply this with r. So u dot delta into r vector equals to u dot delta, we got this one, u1 dou by dou x plus u2 dou by dou y plus u3 dou by dou z into r vector is xi plus yj plus zk. Now watch carefully. If we differentiate, now if we multiply, see, we get like this, u1 dou by dou x of xi plus yj plus zk plus u2 dou by dou y of xi plus yj plus zk plus u3 dou by dou z of xi plus yj plus zk. Now the last step is here, equals to u1 into, if we differentiate this with respect to x, We don't have x here 0, x here 0, x is 1, 1 into I is I, plus u2 into, with respect to y means y is 1, 1 into j is j, plus u3 into k. So we got this as u vector. This is the u vector. We have started with this u vector. We have taken this one as the u vector. So this is u. Therefore, we got the answer. Now see the next question. If r equals to xi plus yj plus zk, we have to prove divergent of r equals to 3, curl of r equals to 0. We already wrote in the previous classes. Suppose this, we denote this by r1, this by r2, this by r3. Okay, so the divergence of r will be dou r1 by dou x, dou plus dou r2 by dou y, plus dou r3 by dou z. We already done these questions previously. So dou by dou x of r1 is x, dou by dou y of r2 is y, dou by dou z of r3 is z. So d by dx of x is 1, similarly y is 1, similarly z is 1. 1 plus 1 plus 1 will be 3. Now see here, next question, curl. We know curl is the determinant I, j, k, dou by dou x, dou by dou y, dou by dou z, x, y, z. Now let me expand this. So I into, we have to multiply this dou by dou y of z minus this dou by dou z of y minus j into, so j means this into this dou by dou x of z minus dou by dou z of y x. Then lastly plus k into, plus k into dou by dou x of y minus dou by dou y of x. You see here, this will become 0, I into, differentiate with respect to y, don't have y, this is constant 0. With respect to z, this is y, so it's constant 0, minus j into, with respect to x, we don't have x here, 0 minus 0, plus k into 0 minus 0. So we'll get the answer as 0. Now you see the next question. What we have to prove? Divergent of r power n into r vector equals to n plus 3 r power n. We already know what is the vector r and r square, and dou r by dou x, dou r by dou y, dou r by dou z. We already learned this. Now we have to continue from this. What we have to find? Divergent of r power n into r. Let me do one thing. R power n into r, let me find r power n into vector r is xi plus yj plus zk. So let me multiply this. It will be r power n xi plus r power n yj plus r power n zk. Suppose this is r1i plus r2j plus r3k. Now what is the formula of divergent? Divergent of r power n to r vector. Now this formula we already know. This is dou r1 by dou x plus dou r2 by dou y plus dou r3 by dou z. We can use directly this formula. Now dou by dou x of r1 is r power n into x plus dou by dou y of r2 is r power n into y plus dou by dou z of r3 is r power n into z. Let me use sigma just to solve this one and expand. Okay, in place of these 3 we can write sigma dou by dou x of r power n into x. Now this we can use as uv formula. We have to differentiate, we are multiplying this, so u d by dx of v plus v d by dx of v. Sigma u means r power n, d by dx of x is 1, u d by dx of v plus v means x, d by dx of u, d by dx of r power n will be n into r power n minus 1. But we have to differentiate with respect to x, with respect to x, therefore we have to write dou r by dou x. Now let me expand this, we will get 3 terms. If we expand this, same you write like 3 terms like this. First one is r power n plus nx r power n minus 1 dou r by dou x. Similarly, now the next term will be same like this with y. So you will get like this r power n plus n into, in place of x, y. In the same way, we have to write in, with respect to z also. Expanding now, same symbolic, plus r power n plus nz into r power n minus 1 dou r by dou z. Now let me do one thing. Let me add this r power n plus r power n plus r power n. This will be 3 r power n Now this and from this, let me take common n into r power n minus 1. We can take common. So what is left here? X dou r by dou x plus y dou r by dou y from here. From here, z dou r by dou z. Now let me change this. 3 into r power n plus n into r power n minus 1 x dou r by dou x. We already have this x by r plus y. We are having this y by r plus z. We are having this z by r. So x into x square plus y square plus z square. So let me continue. 3r power n plus n into r power n minus 1. Let me take LCM. This will be x square plus y square plus z square. But we know x square plus y square plus z square is r square. 3r power n plus n into r power n minus 1 into r square by r. If you cancel this, you get r power 1. Bases are same. If you add powers, minus 1 plus 1 we get cancelled. 3r power n plus n into r power. If you take else bases same, powers add, n minus 1 plus 1 plus 1 minus 1 get cancelled. You're left with r power n. Now last time we take r power n common. What is left here? 3 plus what is left here? N. So this is the proof we have to do. Now you see the next question. Divergent of vector r by r cube equals to 0. We have to prove. We already written this. We are continuing from here. So what we have to prove? Divergent of vector r by r cube equals to 0. First let me find this vector r by r cube. Vector r is xi plus yj plus zk divided by r cube, means you bring this r in the numerator, it will be r power minus 3. R power minus 3. So multiply this x into r power minus 3 plus I plus y into r power minus 3 into j vector plus z into r power minus 3 into k vector. So now suppose you consider this as r1, r2, r3. Now divergent of r vector by r cube. What is its formula? Just now we have done the same question. We know this is dou r1 by dou x plus dou r2 by dou y plus dou r3 by rz. So this will be dou by dou x of, this is x into r power minus 3, dou r1 by dou x. Dou by dou y of this is y into r power minus 3 plus dou by dou z of z into r power minus 3. Then we take sigma and expand. So if we take sigma, we just take one term here. So this can be written as sigma dou by dou x of x into r power minus 3. Now let me differentiate multiplying uv. U d by dx of v. U d by dx of x power n is n into x power n minus 1. But we are differentiating with respect to x. So we have to write dou r by dou x plus u d by dx of v plus vi means r power minus 3 d by dx of u. D by dx of x will be 1. So let me expand this for 3 terms. You see here, watch carefully. This is minus 3x r power minus 4 dou r by dou x. Dou r by dou x plus r power minus 3. Let me do one step more. This is sigma. So what is dou r by dou x? This is x by r. Let me write this x by r. So this will be sigma minus 3 into x into r power minus 4 into x by r plus r power minus 3. So you see here, x into x will become x square. If you bring this r in the numerator, r power, this is 1. If you bring here minus 1, r power minus 4, r power minus 1 will be r power minus 5. This will be minus 3x square r power minus 5 plus r power minus 3. X into x square r power minus 4 by r power 1 is r power minus 5. In the numerator, this will be minus 1, minus 4, minus 1, minus 1. Now you expand this, will get 3 terms. Minus 3x square r power minus 5 plus r power minus 3. In the same way, in terms of y, minus 3y square r power minus 5 plus r power minus 3. In the same way, z plus minus 3z square r power minus 5 plus r power minus 3. You see here, we can take common from this 3. What we can take common? Minus 3 r power minus 5. If you take common, here left with x square, here we left with y square and z square. plus this is r power minus 3, r power minus 3 plus r power minus 3 plus r power 3, r power minus 3. Now x square plus y square plus z square is r power minus 2. Sorry, r square. X square plus y square plus z square is r square plus 3 r power minus 3. This basis same adds the power, minus 5 plus 2 will be minus 3. Minus 3 r power minus 3 plus 3 r power minus 3. This plus minus terms will get cancelled, we will answer 0. So this is the question. Inshallah, in the next class, inshallah, we are going to continue some more questions based on vector differentiation. After this chapter, inshallah, we are going to start vector integrals. So I request all the students to follow the channel, follow this, share and subscribe and like my video. Inshallah, we are going to continue the next class.